Okay, so we are going to discuss section 6.3 complex fractions. What we basically have to do is simplify the numerator and denominator and divide by multiplying the numerator, by the reciprocal of the denominator, and then simplify if possible. Some things you have to pay attention to are, first, remembering to multiply by the reciprocal. Next thing you have to figure out is if you have two single fractions, like the first case, then you're good to go. Okay. Also, there are two methods, so we're going to do method 1 and then method 2. The next thing you need to know is if they're not single fractions. So in these two cases, we have to make them single fractions, must make then you can go back to here. Okay, so obviously we're going to start off simple and then go to some more complex examples. Oops. Give me 1 second to clear out what we did in class. Okay, I have erased everything we've done from class, so we are good to start going again. All right, so the first thing you want to start with is finding if both the top and the bottom of the fractions are indeed one singular fraction. Now you can see in part A that if we do this kind of like in, oops. Okay, if we do this, kind of looking at each piece as a qualifying moment, we have the top is one fraction. So that's a go. And then we have a bottom. The bottom is one fraction. And that's good too. Okay, so both of those are good to go. So now what we have to do is just make sure that they're good to be simplified. So we're going to do t plus 4. You can't pull anything out of there. We'll go ahead and separate the 3 and the t. And then what we have to do is we have to multiply by the reciprocal. So we're going to flip the second fraction. So we change it to a multiplication. And then the 9t was on the bottom. It will now come to the top. And then we can't pull anything out of the bottom. Or sorry, the 2t plus 1. So we're done there. 3t goes into 9t 3 times. So you will have a final answer of 3t plus 4 over 2t plus 1. And you can't do anything else. If you wanted to distribute, you could, or you can leave it like that. I would leave it like that. Okay, so let's try the second problem. And kind of the same thought process. We have to see, does the top have one solution? Not solution, one fraction. And the answer here is no. So then you have to make it have one. So the LCD in this case, the only denominator available is y. Well, y and 1. So if you're going to put a y on the bottom, you have to also match it with a y on top. So then you're going to end up with 5y minus 2 over y. Same question for the bottom. And it's got the same basic answer. You want to use, oops. You also want to use y because your only other option is 1. So if you put a y on the bottom, you have to put a y on the top. Okay. And then you just make it the big fraction again. But what we're going to do is we'll rewrite the top. And then we're going to multiply by the reciprocal of the bottom. The y's end up canceling. And you're going to have a final answer of 5y minus 2 over 4y plus 1. Okay. All right, that's method 1 in practice, right? Let's move on to method 2. So for method 2, you want to multiply the numerator and denominator of the fraction by the LCD of both fractions considered together, and then simplify if possible. So let's take a look at what this looks like. And I have to do both on here. That's fine. We can do that. What you should notice is that the first question is a repeat. So you should already know the LCD for this one because it's the only option you have available other than 1. So the LCD for A is going to be y. So again, you have to, and the way you do it this time is you're going to take and multiply. See, that's what it says here. Multiply the numerator and denominator of the complex fraction by the least common denominator of the fractions in the numerator and the fractions in the denominator, and then simplify if possible. So we're going to multiply basically the top and bottom by the LCD, which is y. So we'll have to distribute. So you're going to end up with 5y minus 2y over y over 4y plus 1y over y. And if we simplify, that takes those y's away. And we end up with 5y minus 2 over 4y plus 1. And we should like that because if you go back, these match. Okay, 5y minus 2 over 4y plus 1. 5y minus 2 over 4y plus 1. Okay, now let's do B. So you want to consider the denominators in B. So the denominators right now are 1, x, 1, and x minus 2. Now the ones don't do anything for us. So the LCD is just going to be x and x minus 2 together. So multiplied, all right? So you can either leave it as x minus 2, or you can distribute it and get x squared minus 2x. Either is good, okay? Okay, both of those help. So let's look at let's multiply by the disjointed one. So let's do x minus 2 times x over 1 plus 5 over x, and x minus 2 times 4x over 1 minus x over 2. Okay, so what we'll do is we'll distribute these in, and we'll kind of eliminate or simplify where needed. So essentially we're going to have, and this is where I say this part comes into play. So you know that these two are the same. X minus 2 is equal to x squared minus 2x. So if I bring down, here is the x from the inside. This x is right here, right? So I'm going to say x minus 2x is right there. Okay, plus 5, and I'm going to leave it separate now. X minus 2 over x. This is over 1, and this is all over. Now I have to do the next part. So this we might have to move over. Okay. All right. So we have to get the next part in. So the next part is going to be beneficial again if we do this down here. So x squared minus 2x okay, then minus 1, and we'll just leave it as x minus 2 over let me see if I can okay, over x minus 2. Okay, so then what we should notice is that some of this stuff will cancel. So this x cancels with this x, so you only have to multiply to what's remaining. This x minus 2 cancels, so you just have to multiply to the x. All right, and then we'll distribute the rest of the way. But all the denominators are gone now, so should end up with x cubed minus 2x squared plus 5x minus 10 all over 4x cubed minus 8x squared minus x. And now we could choose to factor by grouping. And here we would have a GCF of x. So then that ends up leaving us with let's work up a little bit. X squared. We're going to pull out we're not just going to pull out an X. We're going to pull out an X squared. Leave it with X minus 2 inside. Plus a 5 pulled out would be X minus 2 inside. So we get X squared plus 5, X minus 2. We're going to pull out an X. So that'll give us X. 4x squared minus 2x minus 1. So we get an overall answer of x squared plus 5, x minus 2 over x, 4x squared minus 2x minus 1. No, this is still an 8. We didn't pull out a 4. Okay, so you could write it like that, or you could leave it here. Either option is fine. Okay. Pearson should take both, and I will take both on your test. All right, what you can see here is that they're showing you method 1 and method 2 with the same exact problem. So you can kind of see a side-by-side comparison, but these are the same, or going to lead to the same answers, even though they are different processes. Okay, so for this one, we have to use both methods for each problem. So we're going to ignore problem B for this slide, and we'll do problem B on the next slide. Okay, so we're just going to focus on A. We'll do method 1 for A. So what you want to do is notice or recall that p squared minus 36 is a difference of squares. So you can write it as p plus 6 and p minus 6. So that's going to help you with your reducing. So we're going to first realize, first we have to ask, is the top one fraction? And then is the bottom one fraction? And thankfully, for this problem, both of those answers are yes. Okay, so then all we have to do is go straight to multiplying by the reciprocal. I'm going to rewrite p squared minus 36 as the factored form. You'll notice that the p minus 6's cancel. So our answer here is just p plus 6 over 5. Okay, that's method 1. Let's also do, as requested, method 2. Okay, again, we have single fractions, so that's good. The LCD you should be able to see pretty easily here. You only have p minus 6 to choose from and p squared minus 36. Well, p squared minus 36 is p minus 6, which is here, and p plus 6. So you want p squared minus 36 as your LCD. So your LCD can either represent it as p squared minus 36 or in factored form, whichever one helps you the best. So what I'm going to use is this one. So I'm going to have p minus 6 over 5p squared minus 36. Now, so on the top, I'll represent it like this. Okay. On the bottom, I can represent it like this. Okay. And you can see that all of them cancel. P squared minus 36, p minus 6, p minus 6. So then your overall answer is the same, p plus 6 over 5. Okay. You have to know both methods for the exam. You have to know both methods for the final. So I would just get to know both of them. If you can choose, then it's totally up to you on which approach you would like to use. All right. Okay, so if you do not like the M and N's for this problem, you can replace them if that helps. I already have my notes set up for M and N's, but if it helps you, excuse me, you can change it. So again, let's work with method 1. And the first question is, and unfortunately, the answer to both of these is no. So the first thing we have to do is we have to get the individual top and bottom to be their own fraction. So for the top, we would pick an LCD of the only things available, m squared, n squared. Okay. So then for this first one, we would have to do I'm just going to write it so you guys can all understand it. And then we'll get rid of what is common. No, I don't like it. It's annoying. Okay, so you have to ask yourself, what does the first fraction need? It needs an n squared. So we have 1 on top, m squared on the bottom. So you need an n squared on the top and bottom. And then the next question is, what do you need for the next part? Well, you need the m squared. So then just the top is now n squared minus m squared over m squared n squared. Okay, that's the top. The bottom has an LCD of mn because that's the only thing available for that. So the top of the bottom will need the n then the next part will need the m. So then that becomes n plus m over mn. Okay, so let's rewrite it. N squared minus m squared over m squared n squared, n plus m over mn. Okay, so we can go to factoring now. Remember, this is a difference of two squares. So we can do n minus m and n plus m over n times m times n, m times n times m times n. We're going to flip the bottom and make it a multiplication, so reciprocal, mn and n plus m. And now we can see items will cancel. So your answer for this one is n minus m over mn. Okay, that is method 1. Now we have to do method 2 for question B. Okay. So we don't have to figure out the fractions. All we have to figure out is the LCD of the whole fraction. The whole complex fraction needs to share one denominator. So the LCD for this one is going to be your bigger LCD between these two. And then that goes over here. So that would be m squared n squared. Okay, so then all we do now is we take our problem and we multiply the top and the bottom by the LCD. And what you'll notice is that it might help if you write it on both sides so you can cross out for each piece. Or you can distribute it, whichever method works better for you. I'm going to write down your options there. But I think what I'll do is distribute it. So you can either cancel it out or distribute it. I'm going to distribute it and then simplify. So you're going to end up with m squared n squared over m squared minus m squared n squared over n squared over m squared n squared over m plus m squared n squared over n. You can simplify right away on the top. The bottom's a little bit harder. You have to realize that there's one m and you'll have one m remaining, the same with the ends. So then we end up with n squared minus m squared over m n squared plus m squared n. It brings us back up here. And you have to remember again that we have the difference of two squares. So n is first. So n plus m and n minus m over, and now we have a GCF equal to mn. So we'll pull the mn out and you'll have n plus m left. The n plus m's cancel and you get n minus m over mn left. And those match. So very confusing, but totally possible problem. Okay. Again, if you need to rewrite it, you can. Okay, so simplifying rational expressions with negative exponents is next. Remember, this is that idea where if you have a negative exponent, you want to bring it to the opposite part of the fraction. Okay. Oh, I forgot to erase it. 1 second, guys. Okay, let's try that again. All right, so what we're going to do is we're going to focus on A for the first slide, and we'll move to B for the second slide. So what we want to do here is before we can solve the problem, we have to move the variables to their proper locations. So anytime you have a negative exponent, okay, we want to move the variable placement. So that doesn't mean like move it to the left or the right. It means to move it, if it's on the top, you move it to the bottom. If it's on the bottom, you move it to the top. Okay. So then what we want to do is, you can see here that our, what we want to do first is we want to make sure that you know where the top and bottoms are. So this is actually going to become a complex fraction. What you need to see here is that this is really r to the negative 2 over 1 minus s to the negative 1 over 1 over 4 r to the negative 1 over 1 plus s to the negative 2 over 1. And now also be careful because that 4 is by itself. It's not with that r to the negative 1. So now that we've done that, we can start moving things around. So this will be 1 over r squared minus 1 over s over 4 over r plus 1 over s squared. It's very important that you do that, because if you don't, you would probably have ended up doing something like this, which I will write down and erase just for the purposes of what you probably would have done, which is more than likely you would have said something along the lines of r plus s squared over 4r squared minus s. You can see these two things are not equal. So don't do that. You want to do it the way that I did it. Okay. All right. Okay, so what's next is we have to find our LCD. All right. And I'm going to use method 2. So I'm going to do the whole thing multiplied by the best LCD for me, which is going to be r squared s squared. So each piece will get multiplied by the LCD. And I'll distribute it. So we'll get r squared s squared over r squared minus 1 r squared s squared over s over 4r squared s squared over r plus r squared s squared over s squared. And now we can do some reducing. The r squareds go away, the s goes away once, the r goes away once, and the s squared goes away. So we have left s squared minus r squared, which that part is a difference of 2 squares. Oh, but there's an s left over. So we'll just have a GCF of s. And then we have 4rs squared plus r squared. And if you wanted to pull out GCFs, we have a GCF of s and a GCF of r. So this answer is fine. This answer is probably not needed. So either option there will be fine. Okay. Make sure you know these are squareds. This is a square. And this is a square. Okay, so either way. All right, last one for section 6.3, and then we will move on to 6.4. All right, so again, you want to put in your ones everywhere. At least I recommend doing that. So 2y to the negative 1 over 1 minus 3y to the negative 2. Once you get the hang of it, you don't have to keep doing this, but I definitely recommend doing it the first few times. Over y to the negative 2 over 1 plus 3 to the x minus 1 over 1. So then that's going to become Let's start moving stuff around. So 2 over y minus 3 over y squared over 1 over y squared plus 3 over x. Okay. You need a GCF now, or not a GCF, an LCD. And we're just going to use x and y squared because that includes all of them. So again, I picked method 2. So what I did is I will take and distribute the LCD to each piece. Okay, so you get and then now we can start getting rid of stuff. So 1y goes away. The y squareds go away. And the x's go away. Bring everything together. You have 2xy minus 3x over x plus 3y squared. Now you can pull out the GCF of x and be left with x 2y minus 3. But you really don't have to because you can't pull out an x on the bottom, so they're not going to cancel anyway. So either option is fine with me. And that is the end of lesson 6.3. We will move on to 6.4 next week, tomorrow. All right, guys, I'll see you at the next recording.